Let's see if this actually works today. Okay, so today we're still going to do trinomials, so we're still factoring trinomials. But today we're going to talk about some situations that make it quicker to factor, where we have a shortcut maybe that we can use. Okay, and it's one of those situations where sometimes I'll say to you, oh, you can do it either way, it doesn't really matter. Okay, and while it is true that you can do it either way, so all the trinomials we're looking at today, you can factor exactly like we did yesterday. So if you want to continue to do that every time, you can, but you will be miserable. It will be a very long unit if you don't learn the shortcut. So trinomials that we're looking at today, what's a trinomial? Three terms, right? So 3 terms. It's still going to be a quadratic trinomial, so a degree of 2, exponent of 2, and 3 terms. Okay, the difference today is that for the shortcut that we're going to look at, so we have a shortcut if a equals 1. So today, instead of being in the form ax squared plus bx plus c, we are going to be in the form x squared plus bx plus c. Okay, because the a in front is always going to equal 1, which means we don't have to write it. Okay, the shortcut does not work if a is anything other than 1. So let's say we want to factor x squared plus 7x plus 12. Okay, bad news is we can't get away from this start where we have to multiply a times c and look for our set. That does not change.
No, we don't have it.
I know, right? The annoying, tedious part does not go away. So our first step is still the same. We are still going to multiply
1 times 12.
a times c. However, the difference today is that because a equals 1, today this is always going to be 1 times c. 1 times anything is just itself. So all we're really going to be looking at is c. All right, so if we're multiplying here, right, we're really going to be taking 1 times 12. What is 1 times 12? 12. And step 2, we are still going to be listing the multiples. We're going to do just like we did yesterday, where we're going to ignore the sign. Okay, so 1 times what?
12.
2 times?
6.
3 times?
4.
There's our list. Everything is positive, so we don't need to adjust anything with the signs. Right, we want the set that adds to be. Kind of writing this a little bit more shorthand than I did yesterday since it's the same steps. Okay, so what pair are we going to pick?
The 3 and 4.
The 3 and the 4?
Yeah.
Right, because 3 plus 4 is 7. Now, here is why it's a shortcut. Once we find the 3 and the 4, we do not need to rewrite it and factor by group it. Okay, instead, once we find this 3 and 4, we're going to write two binomials. It always factors into two binomials, where our variable is going first, but it's not squared. Right, so it's just the variable to the first power. The reason being, right, when we multiply this back out, right, when we do that double distributing, x times x is our x squared. Yes, Yusuf?
What do you mean by number 3? Step 3.
We want to pick the pair over here that adds up to b. Okay, and you're going to fill in these other two pieces right here with the numbers that you picked.
So 3.
So we picked a positive 3 and a positive 4. So this factors into an x plus 3 times an x plus 4. Okay, so y squared minus 9y plus 20. So we'll multiply a times c. What is a times c? 20, right? Because it's just c in these problems. We're going to list our multiples. So 1 times, 2 times, 3 times, 4 times. Right? This is one where everything is negative. Right? Drew's getting that because if we look over here, right, they're both negatives. What pair are we going to pick?
The 4 and 5.
The negative 4 and the negative 5. So we'll have our y.
And then minus 4 and minus 5.
And then we'll fill in a negative 4 and a negative 5. Right, so even though we do have to do that annoying step finding, it does take a lot of the work off the table to not have to rewrite and factor by grouping.
Yep.
So if we actually did the problem like we did yesterday, would it add up to?
No, because this has an A in front,
Yeah.
so that changes. Those are the annoying ones. But the reality is this is what we see more often in the math world. That's the good news. Okay, we tend to see A equaling 1 more often with a lot of the things we're going to look at. Okay, which means you don't want to be wasting time in rewriting factoring by grouping if you don't have to, because it's just a pain. W squared plus W minus 20. A times C is negative 20. Okay, so we'll list our sets. 1 and 20, 2 and 10, 3 and
That's
4 and.
5.
Okay, then we're going to check our signs. What signs do we want?
We want negative and positive.
So negative then positive. We want the larger number to be positive, the smaller number to be negative. what do we want these to add up to? 1, right? We don't see a number right here, but there's really a 1 here. So we need the pair that will add up to positive 1. So what are we going to pick?
-4 and 5.
Guys are rocking it this morning. Okay, so what does this factor into?
W
-4.
and then
And W